Hello everyone, welcome back to your online learning channel, and in this video we're going to continue proportion part of ratio and proportion of chapter 7 exercise 7.2. So in this video we're going to discuss proportion. So what is proportion? Let us see. An equality of two ratios is called proportion. Okay, so when we have two ratios and we equate them, it is known as proportion. If we have four quantities A, B, C and D, and the ratio of A is to B and the ratio of C is to D, when they are equated, now we say that the four quantities are in proportion. And we also say A is to B is same as C is to D, because this is these ratios are equal. Okay, so A by B equals to C by D. We write it as A is to B is same as, we have two columns over here. Okay, so A is to B is same as C is to D. So this is all about proportion, very simple. We are just equating two ratios. Okay, so we can see that A by B equals to C by D, and hence it is AD equals to BC. If we take cross multiplication also you get that, but we can say that A and D are the extremes. Okay, so you can see A is same as C is to D. So you can see the part A and D lie at the outermost part, and hence they are the extremes. So the product of the extremes is equal to the product of the means. Okay, so what are the means? The numbers or the quantities that lie in between are known as means, and hence we have AD equals to BC. Even if you write it in ratio format, fraction format, A by B equals to C by D, and you do cross multiplication, we get A into D and B into C. So that is AD equals to BC. Okay, now what is continued proportion? Continued proportion, we have three non-zero quantities of the same kind, and we take the ratio 1 by 1, are said to be in continued proportion if the ratio of A to B is equal to the ratio of B to C. So A by B equals to B by C. So instead of having four quantities here, we have three quantities, and the middle quantity is being repeated, continued. Okay, so that is why we say this is continued proportion. And if we extend it to more quantities, we get A by B equals to B by C equals to C by D equals to D by E. Like that it goes on, and it is known as continued proportion. Okay, so as we say, there are two models, so we can compare their heights. Okay, so the ratio of their heights we get, suppose this is model A and this is model B. So the ratio of A is to B height is, say, 2 is to 3. Okay, now when you compare it to another model, basically a face here, so this is model number C and this is model number D. So C is to D, and their length from the tip of the mouth to the tail is, when compared, say 2 is to 3. So we are not comparing this model with one of the faces, but what we are doing is we are comparing the ratios. Okay, so we can see that the ratios are equal. Maybe say 4 feet, model A is 4 feet and model B is 6 feet tall. Okay, so that is 4 is to 6, ultimately we get 2 is to 3. And here also say 2 feet and this is 3 feet. Even then we have the ratio 2 is to 3. So what do we get? We get their ratios equal, and hence we say all these models are in proportion. Okay, so basically we are comparing two quantities in one ratio, and then we are comparing two quantities in the other ratio, and then we are equating those two ratios. That is what we say the numbers are in proportion. Okay, so if we have four quantities, A by B equals to C by D. So if we take cross multiplication of those two, or we say the product of the extremes AD equals to product of the means. What happens when we have continued proportion? We have three quantities, B being repeated, so A by B equals to B by C. The three quantities A, B, C are in proportion when we have this condition fulfilled. Okay, now in that case also we have the same process. We take the product of the extremes, that's A into C, equals to product of the means, that is B into B, so that's B square. So that's why we have B square equals to AC and B equals to root over AC. So as you see from where you have four quantities here, and here you have three quantities, but it doesn't matter because the process is same. You don't have to remember this AD equals to BC or B equals to root over AC. What you need to know, just product of the extremes, product of extremes equals to product of means. This is important. If you remember this, everything is going to be easy. Now again, if you have four quantities in any question, you may get one quantity unknown. Suppose C is unknown, you can easily find C when the rest of the three are given, or say B is not given and the rest of the three are given, so you can easily find any one unknown out of the four quantities. And here you can find any unknown if you have any other two quantities given. Okay, so the first one is known as first proportional here, and this when we have four quantities, this is called the first proportional, this is B is called the second proportional, C is called the third proportional, and D is called the fourth proportional. Okay, now here also you have first proportional, and B is known as mean proportional, and C is the third proportional. Okay, so that's simple. Where you have four quantities, you have first, second, third, and fourth proportional, and where you have three quantities, you have first proportional, you have third proportional, and the middle one is known as mean proportional. Okay, so that's the thing you need to remember, and the whole exercise is simpler. Okay, now let's see some questions from exercise 7.2. Okay, as you see, we have to find the value of x from the following proportions in question number 1. So as I told you, out of four quantities, any one will be unknown. Let us choose any one of this. So the fourth one is x is to 50 is same as 3 is to 2. So we take product of the extremes, that is x into 2 equals to 50 into 3. So we can easily find x, 50 into 3 by 2, 150 by 2 is 75. Okay, seeing the next question, question number 2. Here you need to find the fourth proportional. So it is not given here, but you can consider it as x. Okay, so let the fourth proportional be x, and then we can continue as we have done in question number 1. So we find x equals to 7.5. Going to the next question, we have question number 3. Find the third proportional to. Okay, now here you have two quantities and they are asking you to find the third proportional. That means there is no fourth quantity and hence this is in continued proportion. Okay, so what you are going to do is you are going to take the middle value two times. So 5 by 10 equals to 10 by the third proportional. So let us assume that the third proportional be x. Let us take the fourth one. So 5 1 by 4 is 21 by 4 and 7. So the ratio of 5 1 by 4 is to 7 is same as 7 is to x. So the third proportional is x, and we can easily find x. So that is 9 1 by 3 and the third proportional is 9 1 by 3. Now in this question, question number 4, you're going to find the mean proportional. So first and third is given. Let the mean proportional be x, and hence 8.1 is to x is same as x is to 2.5. So we can easily calculate x using mean square equals to AC. Okay, so x square equals to mean proportional square. Okay, so that we get root over 20.25, we get 4.5. Question number 6, we have what number must be added to each of the following numbers so that they are in proportion. Okay, this question came in 2009 in ICSE board. So let the number to be added be x. Now what do we have? The four numbers: 5 plus x, 11 plus x, 19 plus x and 37 plus x. Now when we add x, they are in proportion. So we write 5 plus x is to 11 plus x. That is same as 19 plus x is to 37 plus x. Again applying that product of extremes, that is 5 plus x into 37 plus x. You can easily see that this is the first term and this is the last term. So the product of the extremes is equal to the product of the means. So we get, by multiplying and calculating, solving for x, we get x equals to 2. So the least number that is to be added to each of the given numbers is 2. So in this question we have two conditions. If you see properly, we need to find two numbers such that the mean proportional between them is 28 and the third proportional to them is 224. So the first condition is mean proportional given and the second condition is the third proportional given. So we have to assume that the two numbers be a and b. Okay, so let the two numbers be a and b. This is the first according to the first condition. According to first condition, okay, we have 28 is the mean proportional, so a is to 28 equals to 28 is to b. So that means 28 square equals to ab. Okay, so ab equals to 28 square, and we have taken a equals to 784 by b, that's 28 square by b. And from the second condition, this is according to the second condition, according to second condition, we have the third proportional to the two numbers a and b 224. So a is to b is same as b is to 224. So we can say b square equals to 224a. Now the reason we wrote a equals to 784 by b is that we are going to put 784 by b in place of a. Okay, so once we do that, we get b cube equals to 224 into 784, and ultimately on calculating we get b equals to 56. Now the thing is, this is from the first condition we get one equation. We can use this one too, no problem. and from the second condition we get another equation. So these are the two equations with two variables, so we can easily calculate one of the variables. Okay, so here we have used the substitution method to find the values of b. Now we can continue use the value of b in one of those equations and find a. So what is a? A is 784 by b, and we get 14. So the numbers are a is 14 and b is 56. That's all for now in this video. We'll see some more questions from the same exercise in the next video. Thank you. See you in the next class.